Good morning, students. I am Manikant Mishra, Modern English School, New India. So today we are going to discuss the characteristics of periods, gradation of properties or gradation of influence like a valence electron, valency, size of atom, ionization enthalpy, reactivity. So let us discuss one by one of this gradation along the period. So characteristics of a period. Characteristics of period. So in one of the example, if you consider of any one of the period like a sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. It is one of the periods. All these members belongs to the same period. So if you are going to write the electronic configuration of these elements, like a sodium 281, 282, 283, 284, 285, 286, 287. So now you can understand, you know it now that this is of which group, of which period they belong. Obviously you will say this is an example of these elements belong to third period. These elements belongs to third period. So it is an example of a third period elements. Because here n is equal to 3. Number of cell in which the electrons are being filled is 3. 3, 3, 3, 3, 3, 3. KLM, 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 KLM. So 3 periods are, 3 cells are involved. So we can say these are the elements belonging to third period. Now, what is the gradation? What is the change in their properties like a valence electron? Valence electron. Now you see how many valence electron the sodium has? 1. How many valence electron magnesium has? 2. Aluminum has 3. Silicon has 4. Phosphorus has 5. Sulfur has 6. Chlorine has 7. So what is happening while moving from left to right? While moving from left to right across the period. While moving from left to right across the period, number of valence electron increases. Please keep it in mind. While moving from left to right, across the period, while moving from left to right across the period, number of valence electron increases. 1, 2, 3, 4, 5, 6, 7. So this is one of the characteristics of the valence electron, that while moving from left to right, valence electron increases. While moving from left to right, number of valence electrons increases. So regarding the valence electron, so question often comes what is the effect of the valence electron when we move from left to right. So while moving from left to right along the period, we are talking about the characteristics of a period. So while moving from left to right across the period, number of valence electron increases. Now next property, valency. Now sodium has valency 1, magnesium has valency 2, aluminum has valency 3, silicon has valency 4, phosphorus has valency 8 minus 5 3, sulfur has valency 8 minus 6 2, chlorine has valency 8 minus 7 1. So now sodium has valency 1, magnesium has valency 2, aluminum has valency 3, silicon has valency 4, phosphorus has valency 8 minus 5, that is a 3, phosphorus has valency 3, sulfur has valency 8 minus 6 2, so sulfur has valency 2, chlorine has valency 8 minus 7 1, so chlorine has valency 1. Now you see that gradation along the period. So number of valency 1 2 3 4 3 2 1, 1 2 3 4 3 2 1. So while moving from left to right, across the period, valency first increases and then decreases. Valency first increases and then decreases. I am writing here, while moving from left to right, valency first increases and then decreases. Now, while we are talking about the effect of valency along the period. So as I said, you see that sodium has valency 1, magnesium has valency 2, aluminum has valency 3, silicon has valency 4, phosphorus has valency 8 minus 5, 3. So phosphorus has valency 3, sulfur has valency 8 minus 6, 2. So sulfur has valency 2, chlorine 8 minus 7. So chlorine has valency 1. So now while it means you see that while moving from left to right, so when you move 1, 2, 3, 4, 3, 2, 1. So it means what is happening up to silicon, it is a increasing. Up to silicon, the valency is increasing, and thereafter is decreasing. So up to silicon, valency is increasing, and thereafter there is a decreasement takes place. So what we can say? So while moving from left to right, while moving from left to right, valency first increases and then decreases. While moving from left to right, valency along the period, while moving from left to right along the period. Please make correction here also. Okay, upward. While moving from left to right along the period, valency first increases and then decreases. So this is called the gradation along the periods, or the characteristics of period. So first is what? Valence electron. First characteristics, valence electron while moving from left to right along the period, number of valence electron increases. Here you see the number of valence electron 1, 2, 3, 4, 5, 6, 7. So number of valence electron while moving from left to right across the period is increases. So once again, just to recap it, as I said, we are going to discuss the characteristics of period. So the very first is valence electron. As you know that what is a valence electron? The electron present in the outermost shell is called valence electron. So I have taken the example of the group third period. Third period. So third period member is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So now if you write its electronic configuration, 281, 282, 283, 284, 285, 286, 287. Because chlorine has atomic number 17 or silicon has atomic number 14. So that you know it's very well how to write electronic configuration of a particular element. So we always write the electronic configuration of its atomic number. So don't confuse it. Some of you yesterday you have made mistake. So please keep it in mind. Always we write electronic configuration of atomic number, not of the atomic mass. Make it very much clear. So now, if you see, the valence electron of sodium is 1, magnesium is 2, aluminum is 3, silicon is 4, phosphorus is 5, sulfur 6, chlorine 7. So what is happening when we move from left to right across the period? While moving from left to right across the period, then number of valence electron increases. Number of valence electron increases. Again, come to the valency. What is the valency? Combining capacity of an element is called valency. Combining capacity of an element is called valency. So now you see that sodium has valency 1, magnesium has valency 2, aluminum has valency 3, silicon has valency 4, phosphorus has valency 8 minus 5. After 4 we find out valency by subtracting from 8. So valency of phosphorus is 3, sulfur is 2, chlorine has 1. Okay, so what is happening? What is happening here? Valency 1 of sodium is 1, magnesium 2, aluminum 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1. So valency first increases 1, 2, 3, 4 up to it, up to silicon. Valency increases while moving from left to right across the period. And then decreases, and then decreases. So please watch the video. These are very important information for the point of view of the board exam. So if you have, after watching the video, if you have doubt, then please let me know. Thank you. Have a nice day.